So for section 8.1, we're going to just have a quick overview of solving linear equations. And I kind of put it down to 3 steps. Our first thing is, if we got a lot going on, we're going to simplify the equation. That's distributing, clearing any fractions, combining like terms. Once we're done with that, you may end up with variables on both sides. So we isolate the variable, basically get the x or the y onto one side. And then last, we'll solve using inverse operations. If you've had me before, this is pretty straightforward, but I encourage you. We all know for inverse operations, we generally know that inverse means that we use the opposite operation. So most people could tell me to undo adding we use subtracting, to undo subtracting we use adding, to undo multiplying we divide, and to undo dividing we multiply. They utterly undo each other. That's the opposite operation. What I focus on as well is that we do the opposite operation in the opposite order. Meaning what? Well, order of operations is just what? PEMDAS? Now that's if I plug in a number and we start with parentheses, exponents, multiply, divide, add, subtract. Well, with inverse operations, what we do is we start in the opposite order. So I deal with the adding and subtracting first. Then I deal with the multiplying and dividing. Then I deal with the exponents. And we're not going to have all of that going on, but we will soon. So you might as well kind of get used to this now. So when I look at example 1, first, is there anything I can simplify? Okay. Can I combine any like terms? I hope right now you're saying no. A lot of people will want to bring these together, but you cannot add across an equal sign. So what do? Well, we say, well, I can't simplify that, so we will isolate the variable. Basically, I will move the x to get all the x's on one side. So we move a positive 2x by subtracting it away. That zeroes that out, hence making it go away. And to keep it balanced, if we do it to one side, do it to the other. So now we have negative 5 is equal to 3x minus 2. So that is step 2. Step 3, to do inverse operations. I will have some people that will start adding 5 because they're like, well, if 5 is there. No. What's happening to the x, right? This x right here is being multiplied and subtracted. And so, starting with the adding and subtracting, we undo the subtracting by adding 2 to both sides. That gives us negative 3 is equal to 3x. Do not subtract here. That needs to stop. If you're going to do that, then there's a class that covers that. That's the previous one. So make sure you know this is 3 times x. So to undo the multiplication, we will use division. So that x is equal to negative 1, or negative 1 is equal to x. Onward. This next one is not ready to be solved. It has issues, right? I need to clean this up. I need to simplify. That includes any distributing. What distributes over here? Do not subtract those. We have to deal with the multiplication first before we subtract. So this becomes, looks like 10x plus 15 is equal to 3 minus 2 times 3, or minus 6x, minus 2 times negative 5. How about positive 10? We are not done simplifying. On the right side, we have 2 like terms. So we have 10x plus 15. We have negative 6x, and 3 and 10 make 13. Now we are ready for step 2, which is isolate the variable. I cannot combine these across the equal sign, so we move the x. I either subtract the smaller of them, or if it's negative, we can add it over. That zeroes it out, leaving us with 16x plus 15 is equal to 13. And now we're ready to do inverse operations. Undo the adding by subtracting. Undo the multiplying by dividing. Do not leave your answer like this. Make sure you simplify to, looks like -1 over 8. Let's keep going. What do we do here? I see a bunch of fractions. Well, you can leave them all as fractions and mess with the denominator, or you can bust those fractions. This is back to chapter 7, right? I want to find a number that 2, 3, and 4 all go into. I take the 4, 8, 12, 16. I could keep going, but I need something that 2 goes into and 3, and that would just be a 12. Rather than give them all a 12, I'm going to multiply the entire equation times the least common denominator of 12. So to this, and to this. So this gets a 12. The 2 goes into the 12, makes that a 6. I have 2x plus 1 times 6. No more fraction. This gets a 12. I get 12 divided by 3. How about 4? No more fraction there. This gets a 12. The 4 goes into the 12 3 times, so I'm left with 3 times x minus 3. No more fractions. Learn how to clear them. Now we distribute. So 12x plus 6 is equal to 4 plus 3x minus 9. Combine like terms. About 3x minus 5. That is all the simplifying. Get the x on one side. 9x plus 6 is equal to -5. Undo the adding with subtracting, so that 9x is equal to, how about -11? And when I divide, -11 over 9. Here we have decimals. What do? I would just leave them. You could multiply everything by 10. If you do all this times 10, that 1.5 becomes a 15. The x plus 2 doesn't change because the 10 only multiplies to the group. The 2.8 becomes a 28, and the x becomes a 10x. So basically everything gets multiplied by 10. I'm just going to leave the decimal. We have technology, we have a calculator. I can distribute 1.5. 1.5 times x plus 1.5 times 2 is 3 is equal to 2.8 plus x. The rules don't change just because there's more complicated numbers. I'm still going to isolate the variable by subtracting the smaller of them away. We now have 0.5x plus 3 is equal to 2.8. We are going to undo the adding by subtracting. That gives me 0.5x is equal to, how about -0.2? Divide by 0.5. I would be okay with either the fraction 2/5, which is probably what you would get if you did it that way, or negative, sorry, or negative 0.4. Either one is fine with me. How do I solve this? This looks pretty easy. Well, I need to get the x on one side. If I move it over, I'm left with 7 equals 2. I'm solving for x. By the way, x minus x is not 1x. They zero out, right? So I'm left with 7 equals 2. What the heck does this mean, right? Well, I was solving for x, and all the x's went away, and I was left with 7 equal to 2. Is there anything I can do to make that 7 and 2 equal to each other? Not really, right? Whatever I do to both sides, besides like multiplying by 0, which kind of clears everything out, there's nothing I can do here. So there's nothing I can do to make these equal. Therefore, this has no possible solution. The book will call that a contradiction. There's nothing I can do to make this true. See, and go back to the original question. We're saying some number plus 7 is equal to that same number plus 2. That makes no sense. How can I have the same number, add 7 to it, or add 2 to it, and have it stay the same? It doesn't work that way. That is a contradiction. These are never going to be equal. Let's check the next one. 2x plus 2. Distributing that gives me 2x plus 2. Looks kind of similar. Isolate the variable again like we did before. And we get 2 equals 2. Right? What does this mean? I'm solving for x's and they all just disappeared. Well, up here I could never make them the same. Here I could never make 2 and 2 different. There's nothing I could do as long as I do it to both sides. They will always stay the same. This, some books will call this many solutions. I think that's kind of weak. How about infinite solutions? Or sometimes we'll call this an identity. Basically, they're the same. So basically, this is where I wanted to show you. When does 2x plus 2 equal 2x plus 2? Well, always, no matter what x is, those two sides are identical. There's nothing we can do to make them different. If you can solve equations, you should be able to also solve inequalities. Just like we solved equations. How do I undo that subtracting? We add. Some of you had a teacher that told you, we treat this like an equal sign. If you make it an equal sign, that is a bad habit. Do not do that. Leave it as an inequality because there's going to be times where we have to flip it, so don't just do that. What's left on the left side is just x is greater than negative 4. That is the algebraic solution. There we solved it. Next, we need to graph it. How do I graph that? Well, we have a key point at negative 1, 2, 3, 4. X is greater, so we're going to be shading to the right. Some of you would put an open dot here. I don't encourage that. What we did is we used the symbols that we did in Math 55, which is when it's not equal to. We put a parenthesis facing the way we're shading. Since it's greater than, the parenthesis faces the shading to the right. That is the graph. That is the, and I'm not talking about XY axis at this point. We're just graphing this on a number line. The interval notation, we put a minimum and a maximum. Our minimum is how far left does this go? Well, it goes all the way to negative 4. Our maximum, since it goes right forever, is positive infinity. So it goes right forever, which is infinity. What symbol do I put? Well, this parenthesis for the 4, since it was not equal to, also goes down here. Infinity, you can never equal infinity, so it will also be a parenthesis. If this is not review, then I'm going to summarize some of it at the end, but this should be review. On this one, if I'm isolating the variable, problem here is that I have 3 is greater than or equal to m. If you go to graph this, and you graph it to the right of 3, that would be wrong. Well, how do I know? Well, here's the number 4. You just shaded in 4. Is 3 greater than or equal to 4? No, no, no. See, this does not say shade greater. This 3 is greater than or equal to m says that m is the lesser value. M is less than or equal to 3. So that means it'll shade to the left. If that bothers you, then learn to write the m first, the 3, and keep it pointing at the m. Keep it open at the 3 and pointing at the m. So now I have my bracket at 3, shading less than to the left. How do I know this is right? Well, I just shaded 0. Is 3 greater than or equal to 0? Yes, it is. Is 0 less than or equal to 3? Yes, it is. So make sure you check the shading. If you're not going straight from this to the graph, then I'm going to encourage you to learn to rewrite it in that order so that you can see the shade to the left. What is the interval on this? Well, the minimum, we go left forever. That would make that negative infinity. See, infinity is way over here on the right. If I go to the left of 0 forever, then our minimum is negative infinity. Our maximum, we go up to 3. On the infinity, a parenthesis, because you can never equal infinity. And on the 3, a bracket. Why? Bracket means equal to. Like, why didn't we put a bracket on both of these? You cannot equal infinity. 3n is greater than or equal to negative 24. We solve this by dividing both sides by, to get that m is greater than or equal to negative 8. Go back to negative 8. Greater than or equal to, I'm going to have a bracket for the equal to facing the shading greater, which is to the right. What is my interval? Minimum and max. Minimum, how far left do we go? How far right do we go? This time our infinity is positive. On the 8 we put a bracket. On the infinity, always a parenthesis. How do I solve this? Well, it's a two-step equation. We start by undoing the adding, by subtracting. Negative 7k is greater than or equal to 35, and we divide both sides by a negative 7. We divide both sides by a negative 7. See, k was not being subtracted. I will see some people sit there and put a plus 7 here. That will not work. You cannot undo multiplication with addition. We have to undo multiplication by dividing by the same number. Why do I keep focusing on the negative? Because this is the exception with inequalities. Whenever we multiply or divide by a negative, multiply, there we go, or divide by a negative, the inequality must flip. So this situation, it was greater than or equal to, it becomes less than or equal to negative 5. If you've done this, and you're like, well, why does it flip? Well, I can tell you. One thing, if you think about it, whenever I multiply or divide by a negative, everything becomes opposite. See, this k was a negative 7k. It was negative. It's now positive. This 35 was positive. It's now a negative 5. Those both changed signs. They both flipped opposite of what they were. So doesn't it make sense that when you multiply or divide by a negative, if all the numbers and all the variables become opposite, so does the inequality. Okay? How do we graph this? Key point is at negative 5. Less than or equal to, bracket, shaded, left. Another good reason why we flip it, if I hadn't flipped it, I would have shaded to the right, and I would have said 0 was the solution. Check it. Is 0 less than or equal to negative 5? Right? Check it with the original, really. Check x equals 0. 7 times 0. 2 is greater than or equal to 37. That is a lie. 0 was not one of our solutions. Do not graph towards the 0. You have to graph the other way. So you have to flip it. Why? Because everything becomes opposite. Why else? Short answer is, it's not right if you don't. See, we graphed and we shaded negative 6. Check x equals negative 6. Negative 7 times negative 6 would be positive 42 plus 2 is 44, greater than or equal to 37. See, that is true. That's the direction we shaded. One more time for our interval. I know I'm running out of space here. We went left forever, so how about negative infinity up to negative 5. On the infinity, always a parenthesis. On the 5, a bracket to match the other bracket because it equals the negative 5. This is a compound inequality. The book will show you to split this. I don't recommend that. I find students make more mistakes that way. So here's what I would do. What's happening to the x is it's being subtracted by 2. So we will add 2. To what? Well, this has 3 sides of the inequality. So I will add 2 to all 3. Keeps everything balanced. 3 plus 2, I get 5. Less than or equal to, just x, is less than 9. How do I graph this? Well, in this situation, we have 2 key points. We have 5, and we have 9. And this first statement says that x is greater than the 5, so that would be to the right. The second statement is less than 9, so that would be to the left. Some people will shade all the line and just make the middle darker. I don't recommend that. For it to be the solution, it must be true for both. So basically it has to be between only the 5 and the 9. Only the middle we will keep. What symbol do we put on the 5? Equal to is a bracket. The symbol on the 9, not equal to, is a parenthesis. What is the interval for this? Well, our minimum is 5. Our maximum is 9. On the 5, a bracket. On the 9, a parenthesis. The book will sometimes write this as 5 to infinity and negative infinity to 9. I'm technically fine with either answer. I just think the left one makes a lot more sense. Because if I'm doing from 5 to the right forever and 9 to the left forever and this and, we're only keeping the stuff in the middle, technically that's right. I just prefer to write it as a single interval. So you got choices. Example 12. How do I undo? I see k being multiplied and added. We start by subtracting. Negative 4 less than or equal to negative 5k less than or equal to 5. We divide all three sides by, well, it's being multiplied by a negative 5. The negative and negative make that a positive. The negative and negative make that a positive. The positive and the negative make that a negative. What did I miss? This became positive, this became positive, this became negative. Everything becomes opposite. So does the inequalities. Do not forget that. Everything flips, including the inequalities. So, what would this look like as a graph? I'm looking at two numbers again. Negative 1. 4/5. Do not graph that between 4 and 5. 4/5 would be between 0 and 1. How does x compare to the 4/5? Well, 4/5 is greater than or equal to, that means x is less than. So, to the left of that. How does x compare to the negative 1? X is greater than, so to the right of that. I only keep the middle in between the negative 1 and the 4/5. Why do they both have brackets? Because they were both equal to, so they both keep those brackets. What is my interval? My minimum would be negative 1. My maximum would be 4/5. I'm fine with all of this answer. I will say that the book would probably have you put the lesser number first, so negative 1, and then 4/5, and then switch it so it's less than or equal to x, less than or equal to. Either way, I'm fine. If that really bothers you, don't worry about doing that. If you get to that homework question, come talk to me if you need some help with that, or go see a mentor. But in all reality, either one is fine. So that is an overview of this section. It should be review. If it's not, then come get some extra help on this. This is basically an entire chapter in Math 55 that's been condensed into one section. Click on the help buttons, come see me or see the mentors, and you should have no problem completing this section.